Because the monsoon is so powerful, geologists suspect that Everest and the Himalayas are being worn away perhaps more quickly than any other mountain belt in the world. Since 2004, a powerful new technique has emerged that can actually measure how fast a mountain is being worn away. It uses high-energy particles from space.
At present, we're all being bombarded by cosmic rays. They come from distant parts of the galaxy.
When these particles hit a rock surface, a chemical change happens. It's like a kind of cosmic sunburn. Erosion from rivers and glaciers expose rock surfaces to these cosmic rays. And just like sunburn, the longer the rock is exposed, the greater the damage to its surface. By measuring the amount of cosmic sunburn in the rocks, geologists can figure out how quickly rivers and glaciers are cutting into the mountains. But working this out needs very precise science.
The concentrations that we're trying to measure are so small they're equivalent to putting a pinch of salt in an Olympic-sized swimming pool and measuring 1 or 2 grains of that salt.
After years of research, Owen has discovered the maximum speed of erosion. 1.1 inches per year. That's 6 times faster than the Rocky Mountains and faster than anywhere else on the planet.
All mountains suffer from erosion. They're built up by tectonic forces and erosion wipes them down again. The Alps, the Rocky Mountains, the Andes all have erosional potential, but nowhere has such huge erosional potential as the Himalayas. The erosion here is far greater than anywhere else, and the main reason for that is the summer monsoon.
The battle in nature between uplift and erosion continues. But the question remains, which one is winning? Is Everest shrinking or growing? In 1999, a team of geologists set out to answer this question. They placed a small GPS station near to the summit of Everest. After 2 years of monitoring, the team had their answer. Everest was, in fact, still growing, 1/4 of an inch every year. The world's tallest mountain is still getting taller. The investigation into the growth and movement of the Himalayas has revealed the following evidence. GPS data shows a very active mountain belt that is still uplifting. Cosmic ray dating proves that the Himalayas are being eroded faster than any place else on Earth. Geologists now have the tools to predict Everest's future. It and the Himalayan mountain chain will continue to rise. Aided by new technology, discoveries are still being made in the Himalayas. And recently, one reveals that the rise of these mountains was so immense that it might have changed the very course of Earth's history and plunged the entire planet into a deep freeze. Everest, 50 million years in the making. Today, the Himalayas stand as the biggest, highest, and most active mountain range on the planet. They are mountains of superlatives. The deepest valley, falling over 20,000 vertical feet. The highest plateau, the longest sheer rock face. Hundreds of peaks, higher than anywhere else on Earth, and many have never even been named. The formation of the Himalayas has changed the entire landscape, an epic evolution from ocean to immense mountain range, and created one of the world's most important weather systems, the monsoon, which supplies fresh water to 1/5 of the world's population.
The Himalayas in Tibet are a really exciting place to work for a geologist. This is because it's such an active and dynamic environment. Not only that, it's a very important area climatically.
Scientists investigating the Himalayas have uncovered some surprising results. Discoveries which would suggest that the rise of the Himalayas might have had an impact on the climate of the entire planet. The discovery came about almost by accident while scientists were studying a process called chemical weathering. Every time it rains, carbon dioxide in the atmosphere dissolves to form acid rain. When the rain falls, it eats away at rock surfaces. This weathering process takes CO2 out of the atmosphere and locks it away in the rocks.
As that rock is interacting with the atmosphere, it pulls down carbon dioxide, and that leads to a negative greenhouse effect, if you like, an icehouse effect. So you get more weathering, you pull down that carbon dioxide out of the atmosphere, and that leads to cooling.
The more CO2 there is in the atmosphere, the warmer the global temperatures. Take CO2 out of the atmosphere, and temperatures are reduced. Then, scientists discovered a major coincidence. The dramatic rise of the Himalayas over the past 20 million years coincided with the gradual fall of global temperatures, which led to the start of the last major ice age. The pieces of the puzzle fell into place. As the Himalayas uplifted, they had acted like an ever-growing giant sponge and absorbed massive amounts of CO2 from the atmosphere.
The uplift of the Himalayas and Tibet lead into the drawdown of carbon dioxide from the atmosphere by these weathering processes was probably one of the major factors in lead into the cooling that culminated in the ice age that started about 2.5 million years before present.
A cooling effect which was so intense that 2.5 million years ago, it contributed to a global deep freeze. An ice age that affected the entire planet and had a dramatic impact on all life on Earth. And geologists are sure that the Himalayas will continue to exert an immense influence on our planet, as these mountains are still growing. As India pushes northwards under Asia, the building cycle continues. More mountains will form. Over the next 10 million years, 300 miles of land will be forced under Asia. The entire range will grow even taller. Out in this vast wilderness of icy peaks, geologists are still making discoveries.
For geologists, it's exciting in terms of the science because you get to areas where few geologists have been before.
As the research continues at Everest and across the Himalayas, it is a wonder what secrets they might tell us in the future. The evidence for Everest's incredible geological journey has been revealed. Ammonites, evidence that an ocean once existed between India and Asia and that the continents collided 50.5 million years ago. Folds and faults, proof of the initial mountain building process. Granite, evidence of a giant conveyor belt of mountain building power which pushed Everest to its immense height. GPS data reveals that the Himalayas are the most active mountain range on the planet, and Everest is still growing. Everest today stands as the highest place on planet Earth. But in millions of years to come, there will perhaps be another mountain big enough to challenge this giant, living proof that the Earth is never at rest.